Hello, in the last video I did show you how you can install the SonarMapper program on your PC, and in this video we want to focus on what it's capable of and how you can run it. So we downloaded the program here, and as I already explained in the installation video, it comes with an example. We have here now our config file. We need to edit this soon. We have here our test file, and I copied a second file for demonstration purpose, which is not in the GitHub since it's way too big, as you can see. If we open the config file now, we can see that we have different sections, and we will go through them now. We see here that the section about the views tells you that you can enable different views that it should process. So, for example, Downscan, Sidescan, the primary frequency, and if you have a secondary. So we will look at these images later if you don't know how they look like usually on your sonar. But with true, you can turn them on that it processes them, and with false, you can turn them off. Then we have here the georeference entry, which means that it takes the track and puts it on a map without a map behind. So it's not everything just in one line, but if you go curves, then it will plot them as curve. For example, we will look at this. And plot track we already used in the installation video will plot you a map with the track and the depth. The settings section here is not so important. You can leave it as it is. We have here coordinate correction. This is mainly needed for the georeference, since the GPS coordinates are not as accurate as we need them for the georeferencing. So for example, if you have two measurements that are too close together, they will still have the same GPS value. And then we get a very stretched or very compressed actually georeference output. So the thing is, if you use georeference, turn the coordinate correction on. The color map, you can decide how the primary and secondary color map looks like. You can here take values from the matplotlib. For the downscan and the sidescan, because of speed purposes, I implemented my own coloration, and this is not changeable here. And with max depth, you can set at which depth in meters you want to cut the downscan and the primary and the secondary off. This can come handy if you have auto scale on, so it scales for the depth automatically your Fishfinder device, and sometimes in shallow water, for example, it just might scale up to 80 meters, but you actually have the depth is not 80 meters. So you could, for example, set it here to 5 meters, and if you have such a false measurement, then it will not destroy you the whole scan, since otherwise you would have your scan and then you have one big peak to 80 meters down, but what you actually want to see, you can't see. So adjust this to high values if you're not interested in, and if you have problems with such auto scale, then just set it to what your lake usually is there. To the georeference settings, we come later again. Now, an important section is the path. So as base path here, we need to set the folder in which the config file and next to the config file the SL2 files you want to process are. So we take this path, copy it to here, and replace the backslashes by slashes. And now it points to this folder with the SL2 files. And here we can now list the files. So we have here our test file, and we can now copy the second file. So we just add it with a comma, and if you would have the next file, add more commas. And then we have the preprocessing section here, which is necessary. We can look at these preprocessing outputs, but it's necessary to produce everything else. So at the first run, you always have to keep this on, But for example, you could say, okay, I want to have the plot of all my tracks since I was not sure which track was where. And then you are just interested in producing some visualizations here later. So if you have it already run once for the file, then you could turn it off here to save processing time. It doesn't hurt if you keep it on, it just takes some time more. I will now remove this file here again. It was just for demonstration purpose since the presentation PC I set up here does not have the RAM to handle this. Okay, after we edit this file and set the path here, we now save it and then we can open the Anaconda prompt. Again, like in the installation video, we now need to go to the code section. You could as well just point to the code if you want, and you don't need to switch to this directory, but for demonstration purpose now it's easier. We need to activate our created environment. We see that this worked, that it now switched from base to our sonar env. And now we need to call the main program. And as next step, we need to point towards our example, our config. So we copy the path from here, make it full screen, paste it in, make /config ini. And then we can process it. The first thing it does, what you did see here now, is this making the start. This is this R script we will call, which makes this preprocessing. And now it actually starts creating the views. Now it is done and we can look at the result. What we will realize is that we now have a folder, the same named in our SL2 file, just without the dot. And in here we have now the results. We see this SL CSV. This is the one containing the metadata. We can here now see that we have here the metadata. So we have, for example, the survey type label. So this is one line belonging to the primary. This is one line belonging to Downscan. The Sidescan, then we have here latitude, longitude, we have the water depth, the water temperature, and the GNSS position. The SL edited is now more or less the same, but with this fixed coordinates, what I just explained before, what we need for the georeferencing. And then we have here 3 folders containing the downscan, the primary and the sidescan, and the down images, the primary images and the side images. We could now, for example, go to the Sidescan, and then we have per zoom level, we get one of these CSV files here. This contains now for every scan all the grayscale values to the depth. But you don't need to read this because this is what the program does. It creates now out of this data the images, and here you can see now already the images, and we see we have 2 of them because they have a different zoom level. And what you're actually interested in are these 3 images showing now the side scan, for example, assembled. So you see here was a different zoom level, and so it assembled it now. We see here on the left hand side that this is the distance in meters, and so -10, 20, -30, and then here at the top we have the frame ID just. What do we see here? A classical side scan output. We have here some activity directly under the boat going on, something on the ground, and this brighter and darker is because I use different scan frequencies here, so they might appear different. If we now look on the downscan image, then we can see 2 meters, 3 meters, 4 meters. Oops, we did cut it at 5 meters. So it was obviously deeper here. So we need to pre-process this, which is a good exercise anyways. Since it checks for these files, we now need to delete. We want to delete down and primary, downscan and primary image. So we can delete this. Then we go back to our config. We say we want to have downscan. We don't need to process the Sidescan, however. But we could plot the map. And then we need to turn or set the depth here, for example, to 10 meters. Then we again save and let it process. Okay, it finished again. Let's check if it looks better this time. Now we see. It did cut here with 5 meters, but now with the 10 meters, it works way better. And we see this fish activity here too. And this here at the top, this is noise. This was the side scan. This is the map. So you see now we went actually around. And you have the depth here in meters. And the downscan image looks then consequently like this. With the noise here at the top again and the fish. What you can do now, for example, is you can take an app and put the images next to each other if you want to see them at the same time, which is really hard afterwards on the Okay, I now put the pictures underneath each other, so it's now really easy to compare that. For example, here we see this fish and it's even in the downscan, and this could be a lot of small fish. Well, this is maybe one big, and here could be plants, for example. And one can as well lay the side scan next to it. You see if the water depth is reduced, the side scan gets, or this black area here gets smaller, and you see as well the fish, like how they did swim on the side scan. One thing needs to be mentioned: our device stops recording the side scan as soon as you don't display it anymore, but keeps recording downscan and primary. Results in that there are some pieces missing sometimes in the side scan image. You just need to be aware of this. The next thing I want to demonstrate is I want to process the georeference. So I switch everything now. So I turned now on the georeferencing. I turned off the downscan, the side scan, the primary and the plot track. And I turned off the preprocessing since we preprocessed it already. And now we need to go to the georeference coordinates. This now points to the area where you want to have the image pointing at. So we know now, okay, our track was here along. So sideways, we now have the side scan looking sideways out. So we can obviously see more than this track is. So we need to tell now how big of an image it should take to fill with the information from the side scan. To make this a bit easier, you can go to OpenStreetMap, and if you then look where you went, for example, in our case this was here, you can now use OpenStreetMap to select an area, for example, like this, and then you can take the coordinates from here. So we are not actually using the export, but you could use the export then to lay the image underneath later. And these coordinates need to be put now at north, south, east, west. So you're creating an image with these dimensions, and the resolution is now the pixel size here in meters. So we have 0.5 meters per pixel. Be aware, if you make this number too high, then it will take very long to process and take a lot of memory. But I think we could go for a bit more detail here. And then we can run it again. You can as well, of course, calculate all of these things at once if you like. We see now there's mosaic as PNG file and as geotiff. So with geotiff it has the coordinates in, so you can put it, for example, in QGIS. The PNG doesn't. And now we see, okay, from the top we actually went around. So I will add this to our image collection here. You see it's transparent as background, so you can overlay it with other scans. So you see now what was one scan here with a bit of a distortion in the middle was actually a scan this way and back. So this darkish area here is this first part with the other frequency, and the fish activity was here around the turning point, which was somewhere here. So you see here, for example, piece there, piece. As one extra, we can look at this second file I did show at the beginning. I processed it now, and let's see what's in there. First, start with a map. So we see it's a longer track this time, which was already obvious with the size of the original file. We see we are somewhere between 0.5 to 5.5 meters, and it's a long stretchy lake we are at here. So let's start with the primary image. You see these images are getting kind of long and kind of big. But this is good because then we see a lot of details. So you see here at the top again these three lines. This is noise, but you see as well here little fish, for example. You see the different gradients of the ground. We see little plants, for example here or here at the slope where it goes down. We are really shallow. Let's look at the left hand side. It's a bit bad to read, but these are 4 meters here, so each line is a meter. So it becomes really shallow here. It's really difficult for the sonar to capture anything if it's so shallow, and then it went down a lot again. This noise comes from paddling with a kayak. Now we have probably fish, schools of fish or plants. Some big single fish here. Again, unfortunately, a lot of noise up here. More fish, quite likely. And that's it. So let's take a look at the same image on the Downscan. Here we see the noise even more clear. These three lines. We see this plant we had before here at the bottom again. You see it was cut off, so the depth of 5 meters didn't fit for this lake either properly. But we are not missing much here. So you have a clear understanding of the plants up here on the slope. What is kind of good visible is these fish now here. So they look significantly better on here. It could still be plants, but I think it's fish. And again, the others over here, since they're not really connected to the ground. And the vegetation overall is kind of small, as you can see here. Then we can look at the Sidescan image. How far are we looking? We can see 30 meters up to 50 meters sometimes, but mostly 25. This pattern comes from paddling with a kayak. If there are waves and the boat is shaky, then we get these patterns. You see as well here these two, they are not there, but you see here the shoreline. And you see here this noise we already realized in the downscan. Here we have some logs laying in the lake. Now it becomes really shallow, so this is the shallow spot. You see the side scan still works kind of good. Here's a log with its shadow. It was really narrow, the lake at this place. Here we see logs very well, so big trees. And then it got deeper again and more shaky. Here is a big tree. Even going into the area directly under the boat. Here you see seafloor, wave-shaped, and again the shoreline with probably some plants as it looks like. And this could be the fish we did see before, or at least something that is under the boat and kind of high. And here we have again a switch from the 400 to 800 kilohertz. And this view I now prepared in QGIS, where we can show it with a map. So we have now here the aerial image of the lake, and here this greenish is our recorded track. And here, for example, you can see, okay, here it's deeper and wider, and then here it became really narrow. One could have probably as well calculated an even higher resolution on this image. Here we can as well see very nice how it became narrow and how this fits to the map underneath. We have a very narrow channel in the lake, and it represents it really well. Thank you for watching and have fun processing your own files.